Hi everybody, this is Tor Storley and I am back with another video. So in this video, I want to look at the DuckLake extension that duckDB came out with. It is pretty noticeable, and in order for you to use it, you need to download at least 1.3 version of duckDB. Now, the DuckLake allows you to do a lot of new things that was not possible with just a local single file duckDB database before. So in this video, we'll look at some of the features of DuckLake, and I'll explain as I go and try to cover as much as I can about it. And let's get started. So what is DuckLake? Well, DuckLake is a lightweight lakehouse extension for duckDB that enhances the capabilities in several ways. Now, DuckLake is one name for a data lake, but it's not just a data lake. If you have been observing some of these cloud-based solutions like Databricks solutions and others of these cloud-based data storage solutions, you might know that there's one way of just dumping unstructured files up on a cloud storage as a blob service. However, what do you do when you want to track changes to it? Well, that was not easy to do. And with Databricks extensions came the concept of a lakehouse and Delta Lake keep track of changes to their data. Now, you'll find this in most relational database systems. There's nothing new here. It's just that it's been modified for the cloud version of these data storage solutions. So nowadays, the sizes of databases are so large that you have to kind of modify the old relational database structures. Databases like Oracle, SQL Server, Teradata, what have you, they have always had concepts of keeping track of your changes, whether it's SQL Server's transaction logs or, with time you get snapshots, which are more like if you think about your Windows system, for example. If something happens and you download something, install something you shouldn't have, you have an option to restore your system back to a certain point in time. And all this, and the integrity of your data, etc., it's all part of this new DuckLake. So in this video, we want to look at how DuckLake is being envisioned by duckDB. So if you look at a DuckLake, it basically has things like time travel and snapshots. It has ACID transactions, so it ensures consistency across multi-table operations. And it has schema evolutions. So you can modify tables, etc., keep track of those changes for you. It also has partition storage, so you can support multi-file data sets, so you don't have limitations on single-file databases. Also, there's optimized query performance, keeps track of statistics, so you can query those directly without going through all the files to find them. Also, there's seamless integration within duckDB and the DuckLake, so you don't need an external catalog to manage your data. So one of the concepts I just mentioned was the ACID or ACID. And if you look at my points here on the screen, you can see that ACID is a fundamental set of properties that ensures reliability in database transactions. So what does it stand for? Well, you have atomicity or atomicity, however you want to pronounce it. So that ensures that the transactions are treated as a single, indivisible unit. If any part of the transaction fails, the entire transaction is rolled back. So you have such things like begin transaction, rollback transaction. If something went wrong, you can restore it back to a version that was actually correct. You also have consistency, where you guarantee that the transactions brings the database from one valid state to another, maintaining all integrity constraints. There's also something called isolation that ensures that the transactions occur independently and do not interfere with each other. So in other words, it's session-based. So you work in your own little environment, your next guy works in his environment, and it keeps synchronizing all this so there's no conflicts of interest here. Then you have durability. That ensures that once a transaction is committed, the changes are permanently saved. So in other words, once you save it, once you begin transaction, run through all your transaction items, and you commit it, those will be saved and stored on a permanent basis. Now, the DuckLake, they enhance the duckDB by adding this transaction support and making it more suitable for structured multi-user environments. So it's not just you on your local computer anymore. You can actually set up a system here that will keep track of all this for you, so there's no overriding and conflicts between different users. So that's what we're going to be looking for in this video about how they solved this. All right, so now let's take a look at how this actually functions or works. So I'm going to open up an empty instance here. Actually, I'm not going to open up an empty instance. I'm just going to open up a command window so I can show you. So I'm going to open up another command window here. And if you want to install duckDB, a simple way of doing it will be to use this curl command. So let me add that in here. So you say in curl install.duckdb.org pipe bash. And when you do that, it will go out there and it will find the latest version, and then you will actually install duckDB. So this is what it looks like. And you can see that the version we picked up was 1.3.0. So that's the version we want, because DuckLake is not going to work if you don't use version 1.3.0 and above. Okay, so now we have this. Let's just open up duckDB. So we'll type in duckDB like this. So now you get the familiar D prompt, which means you're inside the duckDB shell. Now, what you have to do in order for this to function, you have to install the extension. So you have to install the DuckLake extension, if you will. So we'll install that. And then we can also, if you want the very latest build of this extension or the DuckLake, I don't know if an extension or what it is, but you can use this command, force install DuckLake from core nightly. Then you get the very latest version of this. So as you can see, it took a little bit. That means that the version I had was a few days old, but now it installed the very latest one. 100% you can see. Okay, so in order to work with this, I'm going to use something that DuckDB provides us with, and actually it's a extension. So let me show you what I mean by that. There is something called TPC-H extension. And if you look at the documentation here, you can search for this TPC-H. Now this, as you can see, is an extension that implements the data generator for queries that are being used by this TPC-H benchmark. And as you can see here, if you don't have a newer version of DuckDB, if you didn't follow what I just did and have an older version, you have to install it manually like this. Now, it comes pretty much set up with my install of 1.3.0, so I don't need to do this. Now, what it says here is that you can generate data by calling this function, dbgen. And then the SF is the scale factor. And basically what it boils down to, if you use this SF1, you basically download 1 gigabyte worth of data created for you with this database. Now, if you opt it, you can say 2 or 3 or 100 or 300, and you will increase the size of this database by that magnitude. So if you look at it, this is the kind of tables it will generate. But in order for, if you're going to keep repeating this, you have to drop the existing tables. So you can see this, it's basically an order type of database. So you have customers, you have orders, you have line items, part and supplier, region, etc. So this is kind of a database that's being generated to test these benchmarks. You can read this on your own. But the bottom line is I'm going to use this function to create a database that we can work with. There's also, as you can see here, pre-generated DuckDB databases that uses this format and the different sizes it has. So you can take advantage of that if you want to download that much data. But you can see here, you can get 300, the sizes, and that will generate a lot of data for you. Now we're going to keep it simple, and in my case, I'm simply going to create size of 1 gigabyte. So how do I do that? Well, all I have to do really is call the dbgen like this, and then set the SF equal 1. When I do that, You can see it's running, and it might take a few seconds because it has to go and get all that data. And as you can see, it succeeded. And I don't know what this 0 row means, but okay. So let us now just test this and see if we can see some data here. First of all, I want to see what databases I have in this session here. So show databases. And all you can see here is that it's just memory. Now, if I show tables, let's see what happens here. Okay, so it shows all that stuff. So the bottom line here is that this database was created in memory, and these are the tables. For example, one of the tables is called line item. Try that out. So that's what that looks like. You can summarize it. And another thing I wanted to do was to see if I can get the amount of rows maybe. And keep in mind, the syntax for duckDB is different than normal relational databases, because in every other database you see, you always have to start with the select statement. In duckDB, they have changed a lot of this kind of calling syntax, so you can pretty much mix it up here. Select count, and let's just do a star like this, okay? Let's see what happens. Notice it created about 6 million records here in this memory database. So that means we actually were able to bring in, by using this dbgen function, we created a record that is 1 gigabyte worth of data storage and about 6 million records in here. Okay, that was the line item table. Now there are other tables as well. You have customer table, so you can do describe on the customer if you want to. I wonder if it works with desk only. Let me see. Yeah. So a lot of databases, you can abbreviate some of these commands. Instead of writing out describe, you can just say desk. Okay, so here you can see, here's the description of customer. So let's see how many customers there are. Let's just use our old select here. So let's just change it from customer, like this. And there's 150,000 customers. Okay, you get the idea. So basically, now we got a database in memory. Now, in order for you to create a new metadata storage in DuckLake, what you have to do, you have to attach a data. But before we do, let's take a look and see what the DuckLake is. So as you can see, in this web page, there is discussion about DuckLake ducks. So you can go to ducklake.select and you can find out a lot of stuff. So here you can see we did all this already. We installed the DuckLake. And what you can do now is you can create a new database by attaching. If you want just a local database here, you can declare it like this. Now, there's a couple of ways of looking at this. So here you say attach DuckLake : and then whatever your reference to wherever your database is here. So what do I mean by that? Well, you can create it as a file, a duck file, if you will. You can create it as a database, such as SQLite, such as Postgres, and such as MySQL. And you can also set the path to where you want your Parquet data files located. So you can actually create a file structure here like this. And if you have an existing database, you can attach it such like this. Okay, and then you use the use statement to basically start working with it. You can also see that there are, let me see if I can find this. If you're going to choose a catalog database. So here they give you, if you use duckDB, and this will be like a file system, then you can set up a Postgres SQL here. Notice how they do it. DuckLake Postgres : and then the database name, and then where you're hosting it. Here's on a local host. And you can set up your data path. So that's the Postgres. You can do SQLite like this, DuckLake, SQLite, metadata, and so forth. So you can follow this pattern here. Here's MySQL. And then when you're choosing storage, you can store it on Amazon S3, blob storage, and you can do cloud storage for Google, Azure blob service, etc. So you can choose the way you want to do it. And then you have other things there like snapshots, we'll get into this, schema evolution, time travel, etc., etc., etc. So that's another page you want to go and look at, okay? Now, if you just go to select itself here like this, you can see this is where they kind of introduce you to the DuckLake, so to get started, okay? And it will give you some videos here. It will tell you what it's all about. You know, you can see data lake operation, asset transaction, some of the features. And then they also tell you if you're going to use these different databases to hold your metadata, this is how you would set it up. So take a look at that, and we'll just continue with our presentation here. Okay, so if you go and set it up for like a local storage file, you can do something like this. Attach DuckLake, local DuckLake as DL or DLL if you want. Okay, that's just the same. Now, I'm not going to run this because I already did, but I want to show you the effect of this. So what happens behind the scene is, because I refer to local, it will go to basically my local reference to DuckDB sits under my username, duckDB. So here you can see is all the DuckDB executables that I'm using. You can see it right here. Here's my executable. So it goes right here into this folder where it stores the duckDB installation. And it creates this local DuckLake, as you can see. And that's what that statement is doing. It creates this file, and it puts the metadata inside that file. Now, if you want to create a database version and putting on your local storage, then you could do something like this. For example, here I'm saying attach DuckLake SQLite and then I do /ducklake /SQLite.db. So I give it a name here, and I call it DL-SQL1. And the data path is going to be /ducklake /SQL data files. So what does that do? Well, if we look behind the scenes now, notice I'm referring to //. So that means I'm going to the root directory of my local storage, but then I'm referring to this DuckLake. So if you look here, if I go to my root and I'm looking down here, instead of going to DuckDB, I'm going here to DuckLake, and I'm creating this SQLite database called SQLite-DB. And that's where I'm going to hold my metadata inside this SQLite database, so not in a file that you saw previously. You can follow this pattern here and create these databases wherever you want them to go. So I just want to point that out for you. Now let me get rid of this because I'm not going to run it again. I already have this. So let me take that out. Let us just clear this. Clear C. Okay, Shift C. All right, so now what I can do, I can actually attach a database if I want to. And okay, one thing I didn't tell you is, do you remember from my previous video when I called about Instant SQL? All start UI, like this. And that will basically launch the DuckDB UI, so you can run it in a browser in a notebook format. Once it's loading here, I created this notebook here. But notice on the left-hand side, you can see the attached databases here. The memory, and then you have like a main. And keep in mind, we just did this. We created that ggen, whatever it was called, the dbgen for the benchmark database, the TPC-H benchmark database. And remember, here are the actual customer table. So what we can do, you can actually say query in current notebook, and it will generate the code for you, like you can see here. And then it gives you the results here. Yeah, you can do that. And you can see here, all you have to do to do different things is go to these three dots and say copy SQL definition. That means whatever that table is, the structure of it, and so forth. So you get the idea. Okay, so as you can see, I have attached my SQLite database like this. Okay, and now what I can do is I can say show databases. And if you look, there is a database called __ducklake _metadata DL SQL1. Now, if you look at here, you can see that's the alias I gave this one. So this SQLite database metadata is basically by default called this, and you can rename this according to the DuckDB team. All right, so here you can see it's that one, and then you have this one, and then you have this memory database. Now the __ducklake metadata DL SQL1, that's the metadata catalog that DuckLake automatically creates when you track these snapshots, schema versions or data changes. And you can use the use keyword to actually get an idea what the metadata there is. So let's try that now. Let's use the name here so I don't have to repeat it. So we'll paste that here. So I'm going to use this now. Show tables, for example. And here you can see this is everything there is about the metadata in the DuckLake. There's nothing extra. All these tables here holds different information, as you can see. There's columns, data files, there's delete files, column statistics, partition values. There's changes that happens to your snapshots. There's your snapshot, your schema, etc. So these are the metadata inside that SQLite database that it keeps track of everything that relates to this DL SQL1 database. So I said use this, right? But if you're honing in on a specific database, you can also use a technique like this, where you specify snapshots, DL SQL1. So you're referring to that database that we just used up here, okay? The actual database here. So when I hit enter now, you can see this is the snapshots for that database. You can see, right here, it was created and it was inserted into here because I'd done some insert into this before. And these are the version numbers, as you can see here. Okay, so what I want to do now is I want to say, use the actual database here. I'm going to use this DL SQL1, and I'm going to say show tables. Notice I created a little dummy table before. I called test1. If you wonder what that looks like, let's describe it. It's just an ID and amount. And we can query the data from it, for example. And here's the data. So it's just a couple of rows, as you can see. And if you remember above here, that's what we're seeing here. You insert it into here. If you wonder what it looks like, we had this insert statement, okay? So let me delete everything here. So let me say delete from test1. Okay? So now I delete it. Let's take a look at what it looks like now. Notice here it created another file here. Okay, and that was created right at 11:21:34, as you can see. So it created another file for the delete that we just did. When you do this deletion and all that stuff, you can look at the version. So if I want to say, for example, okay, what happened with the snapshot at version 1? What happened then? Okay, if I run that, you can see there's no rows because that was at this creation point. Okay, there's nothing there. Now, what happened at 2? Well, at 2, you inserted a record, as here, you can see here, and that was at 2:35. What about 3? Okay, now you had 2:35, plus you inserted another record here. So as you can see here, it keeps track of the snapshots. And if you want to bring it back to a certain point in time, you could just create the table and insert from the version, whatever the version was, so you can bring it back to what you want it to be. So again, what happened at 4? Well, we deleted a record, right? So let's see what that did for it. And now you can see there's nothing. So what if I want to add some new records back into it again because I deleted all these guys? Well, let's just insert these records here. So let me see if I can get this to work. And let's do it from test1 now. And as you can see, now I got 2 records back. So what does that snapshot look like now? Well, let's go and get it. And as you can see, it added another one. Now it's 6 in there. So what does that version look like? Well, I'm interested to see what 5 looks like. Okay, it inserted that one. 6 looks, actually let's do 4 again because that's when we're empty, right? What if by 6, okay? So if I do 6, you can see now I got both of them again. So that gives you an idea of how you can time travel and use these snapshots to get an idea of what's in there. You can do a reference to different tables. If I'm going to look at the metadata, I have to go back and say something like, now I can look at the individual, okay, let's just say it, so there's nothing here. Okay, so I can say, okay, look at all the metadata tables, okay? And here they are. So what I can do now is I can inspect each one of these. So what if I want to look at the tables? Well, as you can see here, This is the reference to the tables, and that's the test1 table, as you can see. There's also stats I can run, and here you can see it gives you statistics. The record count is 4, next row ID is 4, and some basic information about that. Another thing I can do is I can query for that test table 1, as you can see up here, and by doing a where clause like this, you can see I'm getting back the information here, the min, the max, etc. Another thing that might be interesting to look at is the data files. Okay, so I can search for the data files. This doesn't really tell you much. You have to kind of hone it in a little because there's too many columns here. And if you describe that, you can see these are the records. So one thing you might be interested in here is this path. So now you can see it gives you the where this Parquet file is stored. It's called DuckLake. Actually, it doesn't leave you the path, but it just tells you DuckLake here, right? So if I'm really looking for this guy here, I could use a reference to the file system. For you to reference the file system, you can use a internal duckDB command, and it's called a glob. Okay, so here you could use something like this to inspect you from duckDB within duckDB. Go to the root node, go to DuckLake folder, search for SQL data files, star. When you do that, you can see there's 4 now, and they sit in this folder location. And this is the name for each one. Okay, now if you want to see behind the scene what that looks like, you can go to DuckLake, SQL data file, and here is the 4 files we're talking about in that glob statement here. So that will tell you where these are stored. Okay, all right. Now, there are more to this. You can experiment with this yourself and look at the documentation. I just want to introduce you to this. You know, you can think about how you can use this, maybe for multi-users in your company or what have you. But I just want to let you know that it exists, but you have to have version 1.3.0 and above in order to use it, and you have to install that extension in order to take advantage of it. So check out the documentation. I'm going to see if I can put a couple of those links into my description of this video. Now, if you like this video, please give me a like and consider subscribing to my channel. That'd be wonderful. And I'll see you in the next video. Have a great day, night, wherever you happen to be in the world.